Hello everyone. Today we're going to talk about two future-proof and tariff-proof facades, a building with local supply chains for lasting performance, presented by Sustainable Project Group and GlasCurtain. The agenda of today will be an introduction about ourselves, a little bit about our companies. Then we will talk about best practices from real-time examples in the industry. I will cover types of buildings. We will also go a little bit into financial justification, and then we will go in building with local supply chains for lasting performance. And feel free to ask questions during the presentation or after the presentation. Presenters of today is myself, Robin Lucidarme, Business Development Manager, and Peter Dushenski, Managing Director of GlasCurtain. Let's start with the first trend that we see in the industry. So currently there's a lot of existing buildings that are here in the left bar here, where we see that their operational carbon is higher and their embodied carbon is lower. So the equipment is using all the energy, and we see that when you manage your own buildings, that you will or replace these buildings and build new buildings, or do deep energy retrofits to reduce your operational carbon. But we see also that the embodied carbon is coming way higher, because you start building air tightness and you work way more in the building envelope. So these are different two trends, don't forget that. So also we see here, for example, the scope 3 and scope 1 emissions in these charts. So I wanted to add this here because as an introduction for Peter. So why is energy conservation important? So first of all, I don't want to highlight that too much, but it has environmental benefits. It has also economical benefits. So it saves energy. So you have less utility bills, and energy is getting higher and higher and more costly. And sustainability, well, it is also good for our planet. So why ways we can conserve energy? So we can reduce our heating and cooling by insulating our home, seal, programmable thermostats, optimize heating and cooling. I highlight that because what we try to do here is, especially when we start thinking about the building envelope and windows, we will now have a better performing building. We need to under dimension our equipment before we're over dimensioning. Also, we have, like I said, so we have better energy efficiency appliances. So now already just for certain equipment, because now we can undersize it again. And I also wanted to talk about lighting as well, because lighting uses a lot of energy, but also from a health point of view, we see that people live way better in natural sunlight. And so also to introduce windows, but I'm actually going to a project in a university where they have installed mirrors to project natural sunlight into the windows, where they don't have natural light. So it has a lot of impact, not only from a sustainability point of view, also from a health point of view. Okay, we focus on two types of buildings. So first of all, type 1 is new buildings, but one type we cannot forget is the existing buildings. We see that from the existing buildings, 50% will still exist in 2050, and that's where we should be net zero. So these type of buildings, so we talk here about new buildings and deep energy retrofits. I wanted to introduce why we need to focus on building envelope, and especially in windows, because when I see the customers that approach us, like the first 3 to 5 years, everybody was talking about the low-hanging fruit, LID, maybe a little bit programmable thermostats and so on, but the trend is changing. We need to now do bigger projects where we do bigger GSG savings. We talk about net zero, passive housing, and the code is also pushing us to become more energy efficient. So why do we invest in better windows, for example? We talk about better energy efficiency, better thermal comfort, better natural light. It also helps with soundproofing if you're in a city, for example. Condensation control, environmental impact. Well, we will use less energy. Durability and maintenance. You can see that and Peter will go deeper in there. And it will also increase the market value of your property if you have good windows. But because certain items, and we talk about the higher GSG saving projects, the payback is not 5 years anymore, or 7 years. We're going in longer. So the question we always ask, well, for us, it's very difficult to get these projects done. So how can we help the industry? And so there are multiple ways of finding money for larger projects. And so that's one thing that we try to help. So one is, in newer buildings, it's mostly also already partly baked in the capital budget. So if you need to build $100 million or a $500 million project, or even smaller, it's already, the architects and the engineers have done it. But from an energy point of view, these are now things that are also available. So you can have energy efficiency incentives, who are municipal, provincial, or federal available. Use these. Then green loans and mortgages. I will give you an example. So certain projects, when you might land at 5% and you say, I will now make my building more energy efficient, you will have access to greener loans. So you will land now at maybe a 4% or a 3%, but on the scale of the project, that can make a huge impact. And so the green loan is already one. And then the amortization rate that might be on 25 or 30 years can now be used at 50 years. So that brings your net operational income better. And so you can justify larger projects. So cost savings justifications, well, you will lower your utility bill. You will do third-party financing or ESCO models, so where you make your CapEx and OpEx. A little bit more popular in the United States, but it's also getting popular in Canada. I've done a couple of projects. You can play with tax credits, accelerated depreciation, and you can do a life cycle cost analysis. So if there's questions here, please feel free to ask me or Peter, because this is basically, that's what people want, but that's how we can implement it. So the majority, we talk about that. Going to this step is the hardest part, but not everybody know all the new ways of doing that. Greg, I see your hand is up. I will go to the next slide, and when that I'm over, I will let you answer or let you ask your question. So second type of buildings is older buildings, and that are deep energy retrofits. They are becoming a lot more popular, especially because a lot of buildings are still there, and we cannot just tear all these buildings down. So we talk about now deep energy retrofits. A little bit very leaky buildings. So why are we going to increase or improve the buildings? So first of all, major source of heat loss. Again, improve the thermal envelope, supports electrification, increased occupant comfort. and that's an important one, especially with larger projects. We see that certain property managers struggle with vacancy, for example. If the building performs better, they will have better occupancy, then they will have better aesthetics and better markability and less vacancy. Better indoor quality, because if the windows will be improved, you will also start playing with ERVs and better ventilation systems. Uh, from a compliance point of view, you definitely want to do that. Then access the incentives, and durability and asset renewal is very important. And then from a financing point of view, utility incentives. So perform utility incentive and rebates, a little bit the same as the new, but there's a lot more for retrofit projects. Integrated retrofit financing packages. There's a lot of retrofit packages available. I don't want to list them up. I hope everybody knows them. Again, you can see grants and low interest loans, the same like I explained before. Carbon reduction grants, performance-based contracts. So if your building needs to reduce 20, 30, 50%, they will now add measurement and verification and do check how your building is performing. Green bonds and ESG linked financing, and capital reserve planning. So please use this a lot. So I see Greg has a question. Maybe Peter, do we have time for Greg's question? Oh, well, Greg, I don't know if you want to talk. Otherwise, you write in the chat. No, I allowed you to talk, but there's nothing. Yeah, you can ask. So I will give the slides to Peter. If there's a question, write it in the chat, or we will try to answer that. Thank you very much. Peter, you're still on mute.
Sorry, I will unmute myself here. And yeah, thank you, Robin, for laying the groundwork. That was good to learn. That's something we don't talk enough about, I feel, in the institutional sort of market that we work in, is the financing part. And that can make such a difference. Especially, I guess, obviously more for the sort of more commercial sort of clients. But yeah, there is a huge opportunity there to take advantage of. I mean, if you can save, 2% on your mortgage or something like that. I mean, I think we all would have an appreciation for how much of an impact that can make. So finally we had Greg. Sorry, that was Robin there. Okay, yeah. Well, I will share my screen then, and we'll chat more about supply chains. All right, let me just get organized here. All right, so we're going to put that. Okay, great. So thank you, Robin, for that introduction, for having me here as well, for having me back. It's been about a year since we've chatted. Last year we were talking about future-proofing facades from one perspective. Today we're going to talk about future-proofing facades from quite a different perspective, but one that's very topical, you might say, one that's very, very much on everyone's mind, which is tariff-proofing and supply chains for lasting performance. I will, and for those of you who didn't read the blurb and just kind of signed up to another one of Robin's presentations, my name is Peter. I'm the managing director of GlasCurtain. We are a Canadian manufacturer of fiberglass framed curtain walls. Actually, you can see those of you who are familiar with curtain walls, you'll recognize that instead of having an aluminum frame back section here, we have a fiberglass frame back section. And then the triple glazing or double glazing kind of goes in this glazing pocket here, and then the same exterior sort of snap cap finish. But today we're going to, discuss a topic that's, of course, increasingly relevant, especially for those of us working at the intersection of energy efficiency and climate action. This is definitely definitely a topical today. So at GlasCurtain, we've certainly seen firsthand how quickly project priorities are evolving and how facade decisions, which used to be just about aesthetics or cost, are now tied directly to resilience, carbon targets, and long-term risk management. So the question is, how do we build buildings that will not just last physically, but strategically? Buildings that perform well in extreme climates, meet aggressive sustainability goals, and are not or minimize the amount to which they're at the mercy of unpredictable global markets. In other words, how do we future-proof our buildings and tariff-proof them at the same time? And of course, we'll be, talking about systems more broadly, but we'll definitely be using, fiberglass frame curtain walls as a focal point, since that's, our area of expertise. That's what we understand the best. But this really is a broader conversation about resiliency, reliability, and rethinking how we build our buildings from the envelope inwards. And the building envelope is such a critical sort of aspect of sustainability, of comfort, of well-being, as Robin was mentioning. There is no replacement for natural light, right? And you can see all the sort of the recent research data sensitivities that people have to LED lights, that they have very, very strange sort of spikes on the sort of electromagnetic curves on sort of spectrums, and it can cause all kind of mess. It can mess up our hormones. It can cause us to not sleep as well. All of these things can be prevented with natural daylight. Of course, we live in, after all, a northern climate. It is a challenge here for much of the year to sort of soak up as much daylight as possible. I live here in Edmonton, so we're one of the most northernmost. We are the most northernmost major city in Canada at 53 degrees north latitude. So we definitely appreciate sort of the long summers, but the very short winters, the very short daylight that we have in the winter, and the criticality and the importance of good glazing. So why now? Why local? So let's zoom out to where this all begins. Energy codes, of course, are rapidly evolving, and we see this in places like BC, Ontario, with the BC Energy Step Code, Toronto with the Toronto Green Standard, for example, but also across the country with the National Building Code and National Energy Code. Whether it's a stretch code, performance-based metrics, or embodied energy carbon calculations, these are becoming standard in many jurisdictions. So carbon budgets, even, especially in public sector projects, are being integrated into the procurement criteria. And those of you who work in procurement, who work in some sort of bureaucratically adjacent kind of space, will certainly appreciate this. And it's and it's getting to the point where whole building life cycle assessment or life cycle analysis is no longer just a bonus. It's no longer just a window dressing. It's becoming a requirement, a foundational sort of piece of the puzzle. At the same time, of course, if that wasn't enough to sort of keep track of, our material supply chains have become a lot less predictable, and we've certainly seen this in the last couple of months. In 2025 here, so lead times have grown, prices have become more volatile, and trade disputes, especially for the very political materials like aluminum, which is actually what typical sort of window frames in the commercial and institutional sort of sector are made out of. The kind of tariffs that we're seeing on these kind of politically sensitive materials, whether it's aluminum, whether it's steel, whether it's eggs, semiconductors, whatever, all these kind of big headline items, are resulting in shipping delays that can disrupt even the best laid project schedules. So in this context, the most valuable thing we can offer is not just high performance, it's predictable performance. Materials that arrive on time, perform as expected, and support long-term climate goals. That's where local manufacturing and materials like fiberglass in particular, because fiberglass is one of those materials we can actually make entirely in Canada. For those of you who are less familiar with the sort of supply chain and manufacturing of aluminum, for example, bauxite, there's not a lot of bauxite. So aluminum actually comes from bauxite mined in the ground. Not a lot of bauxite in Canada. We're a very resource abundant nation, broadly speaking, but most of the bauxite in the world actually comes from Australia, pretty far away. I don't know if any of you have ever been to Australia. It takes a while to get there. And then a lot of that is actually a lot of that smelting that happens, that sort of refining capacity that happens, is in China, right? Not our sort of closest trade ally, sort of North America's closest trade ally at this exact moment. And so most of that capacity for refining and smelting is happening in China. It's like over 80% of the global refining. And then that gets shipped to mostly the United States, actually, for extrusion. So you start with these big billets of material, press them through heated die, and out comes these thin frames or thin tubes. Compare that with fiberglass, which is actually made. It's I'm not going to say it's exactly as simple as just mining a stone, from mining Tyndall stone in Manitoba or something like that, or mining limestone in Alberta. But it is a local material, is a composite material for sure, but it's primarily glass, and we have no shortage of silica and sand in this country. And a lot of the subcomponents, the resins, are also coming from Canada or North America. We're not relying on overseas shipping, trade routes with geopolitically contentious partners. So we're fiberglass is made here in North America, and it is one that we can actually rely on a much more domestic supply chain to supply. So it is very much a local material. But of course, we need to start with the facade. And if you're in this room, you already know the facade is not just the finishing touch, it's where performance starts. So up to 60% of a building's operational energy, especially in cold climates where, again, this is Canada, is directly impacted by the quality of the envelope. This includes the type of insulation, the doors, the windows, and of course the curtain wall systems on commercial and institutional buildings. And of course, curtain walls are a kind of window as well, but they're really a kind of window that spans multiple stories, right? That spans, outboard of the slab edge and extends and really forms the envelope when you have a strong internal structure. So it's non-load bearing in terms of the structure of the building, but it does have to handle the wind loads, and of course is critical for thermal performance and comfort, as Robin was alluding to earlier. So even in projects with modest glazing ratios, so a sort of smaller window to wall ratio, which is the percentage of transparent aspects of the building envelope to opaque aspects of the building envelope. So it's like what percentage of your building is windows, effectively. So even with buildings with smaller sort of window to wall ratios, as we're seeing, as we've long seen, the curtain wall systems still drive the building envelope complexity, cost, and risk. And so it really is critical to get them right. So these are the assemblies that combine the structure, the insulation, the air and moisture control, and of course the aesthetics. They really are the defining aesthetic characteristic of a building. In many cases, it's really sort of the architectural pièce de résistance is very often the curtain wall. And that's a lot of responsibility for one system and for one building component to manage. And this, these impacts are more than about just operational energy. The materials we choose for our facades, so glass, framing, insulation, they make up also up to 40% of a building's embodied carbon impact as well. So up to 60% of the operational, up to 40% of the embodied carbon impact. And then, you could also say at least half of the, at least 50% of the aesthetic impact of the building. Which will also in turn, sort of influence the value of the building as well, right? The resale value, the market value for especially commercial buildings. Obviously, for institutional buildings, Parks Canada, RCMP are not selling their buildings at any point in, anytime soon. Fire halls are not really bought and sold so often. But for commercial buildings, it is critical that the value is upheld, maintained, and maximized as well. So these are strategic decisions ultimately that affect everything from the maintenance budgets as well to the carbon reporting, and that is critical in many jurisdictions. So there's an opportunity because facades are so performance intensive. That's also where we can actually make the biggest gain, right? So we can get better thermal performance values, reduce condensation risk, lower replacement cycles, right? So longer replacement cycles. And when we source it regionally, shorter lead times, lower transportation emissions, and greater quality control. Right. So let's talk about this and how we and how this sort of all fits in together with respect to sourcing locally, and how we can sort of maximize the impact of our facades. So let's take a closer look at supply chain decisions for performance, for timelines, and for carbon, of course, as well. Because the way the materials move, the way raw materials are sourced for installed components, have ultimately a really profound impact on a building's environmental footprint, but also its construction schedule, right? And so it's like, yes, you might want to specify the best product in the world, but if it takes 6 months or 9 months or whatever it is to get there and get stuck at a port and et cetera, what is the risk profile of that specification? And this is where local supply chains really shine. So when you're sourcing from within your region, especially your country, you're not relying on ocean freight, congested ports, changing overseas regulations, or otherwise unpredictable border crossings, right? And so with domestic sourcing, the materials will show up on time, and should anything be incomplete or mismeasured or whatever might happen on site, it's quick to resolve that in a timely manner, and you're not sort of repeating the process over and over again every time there might be even for glass or something like that, you might have a spontaneous breakage. Okay, well, that's no big deal if you have a local glass supplier. You get one in a few weeks. If you have an overseas glass supplier, you could be looking at 24 weeks for a replacement IGU, right? Maybe 6 months. So that is absolutely something to keep in mind. Next, of course, is quality control. So regional suppliers are easier to audit, frankly, and to collaborate with. For example, as a Canadian manufacturer with an entirely domestic supply chain, as we are, we get to work closely with our Canadian subcomponent suppliers to ensure tight production timelines, tolerances, real-time communication, and far few issues downstream. So if something needs to be adjusted, it can happen quickly, not over weeks or months shipping timelines. And then, of course, there's the emissions factor to all of this. Shipping systems, building component systems, especially something as big as a facade system across oceans or continents, racks up substantial emissions. By contrast, local production dramatically reduces these distances and aligns with lifecycle assessment frameworks, contributing to LEED, to zero carbon building certifications, to net zero, and increasingly to local, domestic sort of urban regulations or city municipal regulations that are building off of these frameworks. And ultimately, what this will do is reduce our exposure to global instability. Like, the less we have to read the news, the happier we'll be. The less we have to sort of like guess at what is going to happen tomorrow with this, this trade war, this politician, this blah blah blah. The less we have to all pretend like we're geopolitical experts, the better. Because guess what? No matter how much we read, no matter how well sort of educated we might be on the subject, none of us want that to be our jobs, right? We want to build great buildings, maintain great buildings, and do the best we can for our clients and our communities.
There are two
questions
in the. There are two questions in the.
Thank you, Robin. Yes, fire away.
I will ask the second one first. So Sarah says we're looking for secondary window insert as a retrofit for older office tower in Vancouver, since they have a much lower cost and embodied carbon than a replacement. We would like to source outside of the US given current political and economical situation, but we have found this challenging. Do you have any advice on sourcing them here in Canada?
If you're just looking for replacement IGUs, like just glass units, you shouldn't have a problem with, and you're in Vancouver. I mean, someone like Vitrum and Garibaldi are right in your backyard. And they are glass fabricators. I mean, there's no one in Canada, maybe not even anyone in North America, who will make the flat glass. But they shouldn't have a problem getting the flat glass. And then they're basically fabricating the IGUs, which are the insulated glass units, right in BC, right? So, and the coatings, the coatings are easily available as well from Vitro, from Guardian, from Cardinal. You should have a few options there. But the flat glass, they shouldn't have a problem getting that for you. And the fabrication is all happening, right here in Canada, right in BC. So I would reach out to Vitrum or Garibaldi if you're in that area looking for replacement units.
And then her other question, she said, is what about a fire rating on fiberglass?
Great question. Yes. So this is something where the codes, and we have actually a whole other podcast and interviews and blogs on our website as well, as this has been a topic of conversation since day one. The codes are kind of funny, right? Because aluminum is a combustible material. If you test it to CAN ULC S114, it will absolutely combust. It's basically grandfathered in because there was some funny code sort of changes in the 90s. And we actually had interviewed one of the guys who was on the Canadian Fire Codes Committee at the time, who actually helped us design our fire testing because we had to do additional fire testing to demonstrate equivalency. So suffice to say, long story short, suffice to say, fiberglass is every bit as safe as aluminum in an exterior flame spread application. You can use as much fiberglass of our fiberglass, or certified fiberglass. Not all fiberglasses are certified, but our certified CAN ULC S134 framing system is certified for non-combustible construction, actually in Canada and the United States as well. But it's the CAN ULC S134 is the certification that we've passed. But the nice thing is that the codes are actually realizing that there isn't really material difference between fiberglass and aluminum in a mixture or flame spread in a fire situation, because ultimately it's 90% glass, right? And glass is not combustible. That we know. We're pretty confident that glass is not combustible. And the amount of framing material from a combustibility perspective is quite nominal, even though from a thermal performance perspective, that framing is the primary thermal bridge. So the framing really does matter from a thermal perspective, which is why the codes are actually sort of like rolling back some of the disparate classifications between those between aluminum and fiberglass. And so as a National Building Code 2020 actually rolled back about halfway, and we expect actually the 2025 code will roll it back all the way to demonstrate equivalency between fiberglass and aluminum. So anyways, with our system, you're good to go.
Sorry, if I could just follow up with that, is that something that's accepted by insurance? Because, there's the building code and then it's also our private insurance. And just following up on the first question, the secondary windows, it's actually like a physical insert that is installed in the interior of the window in addition to the glass. So we're not replacing anything, where it's an additive fix that allows us to get in on a weekend, install them, don't have any interruption to our tenants, and significantly reduces our heat loss as well as our solar heat gain, which is becoming even more of a problem in the summertime for our tenants for thermal comfort. So we were looking at a Alpin out of the States, but we're not seeming to find anything that's similar. I think Cascades might be coming up with a product, but it's significantly more expensive than the US. That being said, with the tariffs, who knows? So that's why I was asking.
Yeah, those kind of inserts, not our area of expertise. We don't do those either. We're sort of mostly on the new construction or retrofit of the framing systems. But yeah, I mean, I would just keep calling around, keep talking to talk to the local glazers and see if they have the glazing subtrade. The top ones there, whether that's Columbia Glazing or Flynn or GlassTech or what have you. Talk to them and see what they can source and what they can recommend, because they would have better relationships for that kind of thing. As far as insurance, there's no reason the insurance shouldn't, look at what is certified and what is, acceptable by regulations and have a different standard. So, the building is sprinklered. We have what's certified non-combustible system that's equivalent to aluminum. If they're willing to insure aluminum, there will not be any issue we would not expect with fiberglass.
Thank you.
Thank you. All right. Any other questions before we?
That's it for a moment.
Okay, good. Always happy to thank you, Robin, for flagging that and for bringing those up. I kind of get in the zone, so I need my buddy, to sort of be looking out for me. And so lifecycle assessment frameworks contributing to LEED zero carbon building certifications, and this is key. Yes, reducing our exposure to global instability, whether that's tariffs, whether that's port strikes, as we saw, in the last number of months as well, fuel price volatility, shifting customs regulations, and more. All of these risks and much of the global volatility can be eliminated with domestic supply chains for critical systems. And Sarah brought up a good point there. Sometimes there are good alternatives domestically. Sometimes there are not yet. But if we don't invest in our local domestic suppliers, yeah, they won't exist, right? And yes, they might be more expensive upfront. But like Sarah said as well, once you factor in tariffs, once you factor in, replacements, everything else, it could be that, it could end up being that the domestic one is closer than you think. And this is about, some risk mitigation. But also, again, if we don't support if we don't sort of leverage and make use of domestic manufacturing, it won't exist, right? Domestic manufacturing is not God-given. Doesn't fall from the sky. It's there when we use it and when the market sees that there's demand. And if not, then we'll have to import stuff from Asia, from United States, from Europe, what have you. And we'll just be a natural resource exporting country, right? Industry is not automatic, and manufacturing is not automatic. So we do need to support that, and we're seeing a lot of jurisdictions actually take that very seriously, right? I mean, I was just talking to some architects and contractors from the Okanagan, from Kelowna, and I guess it's like the mayor of Kelowna is like, we have a Buy Canada policy now. That's it, simple. I was talking to another architect from Toronto this week, and it's like, yeah, I know there's a couple other sort of European systems that have similar performance, but we want to buy Canadian, right? And so, that kind of confidence, that kind of you can turn it into a box checking thing. Like, you can turn it into something that's relatable, that's familiar, that's structured, right? This is, and obviously it kind of has to be. It has to be strategic, right? And so when we're talking about climate, talking about cost certainty, scheduling predictability, this is ultimately about project resilience. And whether that's in the capital phase or in the maintenance phase, regardless, this can all be a huge advantage for energy efficient and ultimately resource efficient planning of our projects. So, oops, I jumped ahead. So to focus a minute, yes. So the elephant in the room is definitely tariffs. But this is actually something that we've been paying attention to for kind of since day one, since we started research and development about 15 years ago, because we saw that this was probably a major industry blind spot. So most of us assume that the systems we specify can be continuously available and consistently affordable until they're not, right? So in recent years, a lot of this uncertainty has hit imported systems particularly hard. So it's like, I think this one, from the States will cost X, but I don't really know. Maybe by the time I actually need it to be delivered in 6 months, it'll cost 2X. Or this one from Thailand or from China or from Belgium or from, Spain, I think it's going to cost X, but maybe by the time it actually comes to be delivered, it's actually 2X. Well, that's a big difference. That can be hundreds of thousands, that can be millions of dollars, right? And certainly we've seen this, with something as politically contentious as the U.S. Canada aluminum tariffs, something we're obviously mostly familiar with, since that's our kind of space in the sort of curtain wall framing. But it's back and forth, very hard to have confidence in those systems. And so this issue isn't just one of tariff; it's a broader volatility in global commodity markets as well, driven by geopolitical tensions, currency fluctuations as well, and disruption to supply chains. I mean, remember COVID? I mean, that was a pretty big supply chain shock as well, and that's in recent memory. I hope we haven't all forgotten what that looked like. Lining up, the toilet paper is all gone at the grocery store. But whether it's back in the construction world, of course, that's our topic today, not toilet paper. we can see aluminum prices even, or other sort of sensitive commodity prices double or triple in a matter of weeks or months, and that can really lead to big shocks. And so when we domestically source our products, we can price them in Canadian dollars, which gives us a lot of confidence, a lot of predictability, a lot of assurance, a lot of reliability. And then we are sort of leveraging Canadian manufacturing, and that will insulate us that much better from these international shocks. So we get stability, we get predictable pricing, we get fewer budget contingencies, and systems that arrive when we need them. And this is a big deal for public sector projects, for institutional, and for commercial projects as well. But we're locking in prices for weeks, months, years, sometimes in advance. So ultimately, this will give us, thermal performance, but also economic resilience. And so using these tariff-proof systems, and whether it's facades or otherwise, it's one less variable to worry about. So we can focus on delivering high-performance buildings, not firefighting international trade disruptions. Which brings us to fiberglass. Keep skipping the wrong PDF. So how does fiberglass fit into this equation? As we touched on a little bit already, really quite nicely. So as it turns out, actually the fiberglass manufacturing capital of North America is right here in Canada's heartland, which is the growing city of Winnipeg, which is actually a fantastic city to do manufacturing in because its electricity is also extremely sustainable and low carbon, being that it's almost 100% powered by hydroelectricity. It also helps that Manitoba, unlike some provinces in Canada, has an extremely stable economy and labor force, which really helps when you're manufacturing high-value building materials. So that's where, GlasCurtain, for example, sources all of our fiberglass components, and where we've been working with leading local partners for almost 2 decades now to engineer the highest performing curtain wall framing systems in the world, ones ideally suited to commercial and institutional applications striving for passive house net zero and zero carbon. All of these systems in what we call the ThermaFrame family leverage what's called TPFRP, which is thermoset polyester fiberglass reinforced pultrusions, a bit of a mouthful, but which are ultimately just extremely advanced composite materials with ultra low thermal conductivity and ultra low embodied carbon. So this is about 100 times lower conductivity than aluminum, and 60% less embodied carbon than aluminum as well. Also very thermally stable, this fiberglass frames, meaning they don't expand and contract, degrading the seals on your windows so that, 10 years, 20 years, 30 years down the road, you're not seeing condensation build up on the glass. You're not seeing air, you're not feeling draftiness. You don't have air infiltration, exfiltration. You're not sort of putting pressure on your heating and ventilation systems over time over as well. So that your building performs as well on year 1 as it does on year 10, year 20, year 30, and beyond. And so ultimately, this ultimately can make them very, very durable, and even very condensation resistant as well, which is critical for for cold climates like those so typical of Canada, where the risk of condensation, especially in high humidity environments, is very high, and it is a serious concern. And this can lead to comfort. This can lead to or better comfort, better human health in high humidity buildings. And with our system, we can actually have minus 18 degrees exterior temperature and 50% interior relative humidity with no condensation, and the frame will stay and the glass will stay above the dew point without additional mechanical ventilation. That means no puddles on the floor, no mold on the walls, and no damage to interior finishes. Of course, you would only expect that this would lead to long-term savings, right? Long-term maintenance savings, long-term energy savings. This reduces thermal bridging, maintains air tightness, reduces demand on HVAC systems, and translates to lower operational costs, and then again, better occupant comfort. So you're not having to, down the road in 10 years, 20 years, 30 years, install these extra, sort of lights, extra sort of thermal comfort devices that, maybe you can source from Canada, maybe you can't. As Sarah was mentioning, it's not always so simple to just retrofit things on top later. Maybe Canadian manufacturers don't even make that kind of thing, and then you're sort of at the mercy of the geopolitical chaos. But of course, then there's also long-term energy. And of course the embodied carbon. So our systems are being manufactured in Canada, and fiberglass avoids high carbon production processes associated with aluminum in particular, which are mining, smelting, and global shipping. And so if we zoom out, we can see that fiberglass enables the high performance, low risk, and low carbon building envelopes that hold up over time, resist moisture, and contribute to energy savings from day one. And because they're made here in Canada, they're designed for long-term value. We'll quickly touch on a little case study here, which is a building that's actually just being occupied right now. Took a few years to build, as these things do, and that's the Red Deer Justice Center, located in central Alberta. It's a $250 million courthouse, effectively. And it's actually, if you have never been to Red Deer, which is halfway between Edmonton and Calgary, this is actually the tallest building in all of Red Deer. It's a towering 8 stories tall. But it's a 160,000 square foot building, designed with a relatively high window to wall ratio for the kind of building it is, for the climate zone, and for really the energy performance targets, which are net zero. Designed by DLR Group, with Group 2. This building is really meant to serve as a long-term keystone of provincial infrastructure. That means 24/7 operational performance, a building envelope that's expected to last for decades with minimal maintenance, and some of the highest durability standards in the industry. And anyone who's ever worked with Alberta infrastructure will know how seriously they take their building envelope detailing. And given Alberta's notorious freeze-thaw cycles, where we have also 80-degree swings between winter and summer, we see plus 35 in the summer and minus 45 in the winter. That's a big range for a building envelope to handle. That's a lot of expansion, contraction, a lot of thermal stress. So this facade, of course, needed to limit the thermal bridging, maintain thermal comfort, eliminate condensation risk, of course, and deliver long-term thermal and structural stability. So we work with the project team to implement, actually, it's our standard ThermaFrame 7 triple glazed fiberglass frame curtain wall system, specifically for cold climate institutional buildings. So unlike conventional aluminum frame buildings that often require additional thermal breaks or corrosion mitigation strategies, or even compared to fiberglass window systems that don't properly integrate an air vapor barrier between the glazing and the framing, our fiberglass curtain wall frames, being inherently moisture and corrosion resistant, also ensure a consistent, tight air and water control across the facade, eliminating any weak points that are common in so many systems. The result is less long-term maintenance and significantly reduced energy demands, and the downsizing, as Robin alluded to earlier, of those mechanical systems. So there's operational savings from day one, and even more so in the decades to come. And the overall system performance of this is actually R7, which is about twice the performance of a conventional aluminum curtain wall frame. And this is, again, leveraging domestic supply chains. We're able to meet all the project requirements on time, and the client couldn't be happier to also support local manufacturing. Right, this is a big part of their story as well. We are a Canadian manufacturer, and there's nothing better than sort of giving back to your local community and being able to show your kids, yes, that we were part of that project, and that will be here for generations to come. So the result is a building that's energy efficient, resilient, and built with long-term durability. And this day and age, this is very much something to celebrate. So, of course, in many parts of the world, one of the biggest misconceptions about high-performance building products is that they actually have to come from overseas, and that they can only serve niche use cases, or that achieving top-tier performance requires a single expensive system. We hope to be part of the solution on this as well, by offering. We actually offer 4 main systems: double glazed, triple glazed, vacuum insulated glass, and actually a passive house certified system as well, providing architects with more control, more flexibility, to align with their specific envelope goals, as well as local climates. Right, the climate in Red Deer is not the same as Vancouver, it's not the same as Toronto, it's not the same as Ottawa. Right, Ottawa is much colder as well, or Winnipeg, or certainly when we do projects up in Nunavut and Yellowknife, those are all different kinds of demands as well. But we are able to fabricate our knockdown kits and sell and ship those domestically. And this is really just a good news story all the way around. And of course, we understand that no two projects are alike, right? Ultimately, each site brings its own conditions, its own demands, and its own goals. And so, that can be for some of you reduced maintenance, long-term cost certainty from predictable supply chains, or net zero certification, for example. So this is why we really strive to provide a whole package. And so since we want to leave a couple minutes for questions at the end, we'll just mention that we've covered a lot today, from condensation resistance and material science to the role of tariffs and local manufacturing. But at the heart of the question is, for every capital project, what does this mean for you, and your team and your outcomes? Well, with high performance systems leveraging 100% domestic supply chains, and these systems do exist, it means fewer variables, fewer unknowns, fewer surprises. So when we talk about future proofing, this is one of the big things that we mean as well, especially when it comes to procurement. Systems that meet today's codes, meet future codes, meet a warming climate, meet a cooling climate, whatever the future may hold. A high performance facade is going to be critical to the durability and sustainability of our buildings. And ultimately reducing the moving parts, right? Less, the sort of KISS methodology, right? Keep it simple, stupid. Reducing the moving parts of supply chains, reducing the moving parts of our buildings, right? Less mechanical, less active components, more passive components, more building envelope investment up front, and future-proofing ourselves in the future. So with all of this, we can enjoy shorter lead times, more reliability, and instead of providing excuses, we can provide solutions. So whether you're specifying, fiberglass frame curtain walls or other Canadian products for your next project, today we have the opportunity, arguably even the responsibility, to achieve our project goals, help the environment, and empower our country with domestic supply chains. Truly, believe it or not, this is an exciting time.
We have still one exciting question. Good questions. What's the circularity of fiberglass and end-of-life recycling? Is end-of-life recycling available?
Yes, end-of-life recycling is absolutely available, and fantastic. The great news story about this is actually the people who are actually the sort of industry that's actually pushing fiberglass recycling forward is actually the windmill industry, because they have these giant propellers that only last like 10 years. I mean, curtain wall frames will last 50 plus years, 50, 100 years. These ginormous fiberglass windmill blades only last about 10 years, and then they have to be recycled. And so there's actually a whole industry emerging around fiberglass composite material recycling that's being driven by windmills. And this is happening in North America, it's happening in Europe, happening in Asia, happening everywhere. So the good news is, yes, fiberglass frames can absolutely be recycled thanks to windmills.
Okay, so that's it. So there was one question in the beginning, if we can type in the Canadian glass insert or fabricator. I said we're going to add it in the email, in the thank you email, so that everybody has this information as well. Yeah.
For Canadian glass fabricators?
Canadian glass insert or fabricator. Yes, the ones you mentioned in the beginning to Sarah.
Yeah, the insert. Yeah. And so, we're certainly familiar with the glazing subtrades, who generally work with the general contractors to, install the glazed scope. So they'll do interior glass handrails, they'll do exterior windows, curtain walls, doors, anything with glass. They're called the glazing subtrade. And yeah, they would have certainly expertise on anything to do with glass. So we're happy to, and we also have 35 installation partners across Canada, and so you can actually also just go on GlasCurtain.ca and check out our installation partners, and you can actually see who we work with to start your research, at least, and sort of see who is reputable. And we have basically partners in every jurisdiction in Canada, and you can kind of see if you spot some familiar names and reach out to them directly. We're also happy to make introductions if that feels right, if that's necessary or requested as well. We can always put you in touch with any of them depending on where you are in the country. But you guys have been a great audience today, and Robin, thank you again for inviting, for the invitation, for hosting, as always. And it's great to chat about this kind of topic at such an important time. I mean, this is very, very topical to be thinking about where our materials come from. We sort of focused on the operational impact for a number of years, increasingly embodied impact. But I think where our materials come from has always been a question in architecture, right? In design, it's like only with this very briefly hyper-globalized world did we imagine that we could just add to cart anything we wanted and it would just show up the next day. But for most local architecture is leverages local materials, whether that's the pyramids or the Vatican or temples or mud huts or whatever it was that people have been building for thousands and 10,000 years, always use materials from within whatever 100 kilometers or less or 20 kilometers, right? And so the idea that we would bring something in from thousands of kilometers away is actually pretty new, especially the sort of scale that we ship materials at today in the last 100 years. So if we see a sort of reorganization of the supply chain, it'll take time to reorganize and reestablish, and for people to figure out what can they trust, what can they rely on, what can they get locally. But there's a huge opportunity for people in procurement, for building owners, for manufacturers and suppliers as well, to work together. Always appreciate the chat.
Okay, well, I think there's no questions anymore, so we'll share the slides and or recorded version if people want it for future usage. Otherwise, thank you, Peter. Thank you, audience, and have a nice rest of your day.
Thanks, everyone.
Bye.